So in this video, I want to talk about the process of integration by substitution. And I want to begin by looking at the very same problem that we looked at last time. We took a look at this and we saw that if we were going to find the antiderivative of this, we were going to have to spot the thing that we took the derivative of. We looked at this and saw a pattern that looked very much like what you end up with when you do the chain rule. And we just reversed the chain rule and found an antiderivative. I want to do this again, looking at it in a slightly different manner, but essentially doing exactly the same thing. So let's take this first factor right here. You can see that it's assembled via composition. We have an inside part and an outside part. I want to set u to be the inside part of the composition. X squared plus 3x plus 1. Now I want to go ahead and take the derivative with respect to x. du dx, this will be easy, 2x plus 3. And now I want to remember what we learned near the end of the last chapter, where we started to treat the numerator and the denominator of this expression, even though it's not really a numerator and denominator, as if they were actual independent quantities called differentials. So we're going to treat this and this as if they're independent. We're going to multiply both sides by dx. So du equals 2x plus 3 dx. Now for that to be correct, I have to put the 2x plus 3 in parentheses to make sure that this addition happens before that multiplication. Now let's go back to the original problem. Here we have this expression right in here. That's just u. So let's rewrite this, replacing this expression, cos x squared plus 3x plus 1. That's just u according to our definition. And now look at what we have left. 2x plus 3 dx. That's just du. And we have changed variables. We started off with a problem in x, and now we have a much easier problem in u. It's easy to take the antiderivative of cos u with respect to u. That's just sine u, plus a constant, of course. And now at the very end of the problem, we can translate back from u into x by seeing what we set u equal to. So this is just the sine of x squared plus 3x plus 1 plus a constant. So we started off with a problem in x. We translated it to a problem in u. We did our antiderivative in terms of u, and then we went back to x. And we ended up with exactly the same answer that we had last time. This is the methodology of what's called u substitution.